Okay, in this video we're going to look at how to use the residue theorem to evaluate certain improper integrals of rational functions. So we're going to look at integrals of this form. So these ones are improper because of the limits at minus and plus infinity. So here the function f of x is going to be a rational expression of one polynomial divided by another polynomial. Now these two polynomials must satisfy the following conditions. First, there should be no common factors between p and q, and then q should have no real roots. And then lastly, the degree of q must be 2 or greater than the degree of p. So this must be of degree 2 or greater than this one. So that means this is going to be a strictly proper rational expression. Then the residue theorem. So here we're just going to introduce the method sort of operationally without going into the rigorous details of the proof. The residue theorem says we can convert this into a contour integral where the functional form of this is exactly the same as the functional form of that, and then this is going to be equal to 2 pi I times the sum of the residues of the f of z at singularities that are located in the upper half plane. So only the singularities in the upper half plane are going to have an input or an effect into the value of the integral. So that basically means given an integral, say like this one, so the first thing we are going to do is to check if the three conditions are satisfied. Are there no common factors between the numerator and the denominator? In this case, that is the case. Are there no real roots of the denominator? And in this case, there are no real roots. And then the last one is the degree of the denominator 2 or greater than the degree of the numerator, and the answer is yes. And so in this case, then this would be equal to the contour integral of 1 plus z to the power 4, and then we look for the singularities of 1 or 1 over 1 plus z to the power 4. So this is saying that f of z is going to be 1 over 1 plus z to the power 4. Right, and then we go ahead and look for the singularities. We're going to end this video here. In the next video, we're going to look at the details of how this works out.